Okay, this is for the assignment, Quadrilaterals and Polygons. And with this assignment, we're trying to find out different things, and we're given vertices, and we're asked to find area or perimeter and different geometrical, I don't even know if that's a word, but geometry terms like area, perimeter, different things like that. And we're also asked to find out what the shape is. Well, sometimes you need to just draw it, and it's just simply done that way. You just sometimes need to draw it. And so when we start, we're given these vertices right here. Now, when I printed this, for some reason, the grid didn't print on it, and so I just printed my own. And if yours doesn't print with a grid, maybe you need to do that. And if we zoom in so we can see better, we can see, okay, the first vertex is 0, 3, so X is first, 1, 2, 3. Oh, 0 first, sorry, 1, 2, 3. Okay, and then 3, 0, 1, 2, 3. 1, 2, 3, that's for the 0, negative 3, and the negative 3, 0, 1, 2, 3. And we see that we have a shape being formed here, and it makes a perfect square. Okay, it's just tipped on its side, but you know, perfect square. Now, how do we find out the perimeter? Well, in order to find the perimeter, we have to find the length of each side, and that is something that can be done on a grid like this. If we look carefully, we can see a right triangle. And with that right triangle, we can use Pythagorean's theorem. We can say, all right, the length of this one is 1, 2, 3. Okay, the length down is 3. So now we have two sides, and we can say a squared plus b squared equals c squared. 3 squared is 9, plus 3 squared, which is 9, is 18. So now we have the square root of 18, and that gives us this. And we can do it one of two ways. We can just use a calculator, and we find that the square root of 18 is a very long decimal, but we're going to just round it to 4.24. So I can say that this is 4.24, or we can be exact and factor that down and say that's 9 times the square root of, or square root of 9 times the square root of 2, which is square root of 9 is 3 square root of 2. So that and that are the same, so it doesn't matter how you write it. And if it's a square, that means they're all going to be 4.24, 4.24, and 4.24. Okay, and so if we do 4.24 times 4, that gives us a perimeter of 16.96, or about 17, somewhere in there. But 16.96 or 17, you know, depending on when you want to round it, doesn't matter. But that's how you do number 1. If we move on to number 2, and I'm only going to do the first 2 for you, just so you get an idea. A parallelogram has the vertices, and there they are. Determine what type of parallelogram it is and find the perimeter and area. So this one, we want to find both the perimeter and area. So if we, again, graph it, we can say, all right, we'll zoom out a little bit to graph it, and then we'll zoom back in. So our first point is 1, 2, excuse me, negative 1, 2. I didn't see the negative. And then 4, 4. So 1, 2, 3, 4. 1, 2, 3, 4. 2, negative 1. 1, 2, negative 1. And negative 3, negative 3. Negative 1, 2, 3. Negative 1, 2, 3. And when we draw these all together, we see kind of a squished square. And what that is that's called a rhombus. So if you've forgotten a rhombus. Now, we once again need to find the distance, from point to point. And that's done by using the exact same method. We see, okay, we want to make a point from there to there, and we can say, hey, we can see how big this side is. It goes down 1, 2, 3, 4, 5. So that length of that part of the triangle is 5. And then if we go across, it goes over 1, 2, and we have 5 and 2. The actual formula for this is if you take, let's see, I gotta get another piece of paper here. The actual formula that you're going to look for is y2 minus y1 squared plus x2 minus x1 squared, and then you take the square root of that answer. Okay, and that's how you find the distance. Okay, so we can do it this way by drawing it. 5 squared is 25 plus 4 is 29. The square root of 29, I'm going to use a calculator for, is 5.39. I'm just going to round. Okay, and just so you can see it done over here, I have this point here, which is the 4, 4. So if I have A, B, C, D, A is this point right here, B, C, and D. From B to C, y2 minus y1, so that would be 5. 4 minus a negative 1 is 5, plus x2 minus x1, so that's 2. Notice we're getting the same numbers, 5 and 2, 5 and 2. When we square them, we get 29, and then we take the square root of 29 and we get 5.39 over here as well. And now let's do it for AB. Okay, AB, y2 minus y1, so 2 minus 4 is negative 2 squared, and x2 minus x1, negative 1 minus 4 would be negative 5, and that would be squared. And we're seeing the same thing. We square them and add them, we get 29. So 5.39, 5.39. Okay, so all 4 of the sides are 20. Why did I put 5.39? Oh yeah, sorry. I was looking at the wrong question here for a second. So 5.39, so we have 5.39 times 4, and we see the perimeter 21.56. Or if you keep the square root and stuff like that, you would end up with 4 square root of 29. I mean, those are the same thing pretty much. Now to find the area, you need to find the length of the diagonals. Okay, and so you would find the distance from B to D and from A to C. And once you find the diagonals, you can use the equation for the area is 1/2 diagonal 1 times diagonal 2. Okay, and so find the distance of the two diagonals, again using the y2 minus y1 squared plus x2 x2 minus x1 squared, and then take the square root of all of that. Okay, so hopefully this helps. I'm kind of all over the place on the page there. Sorry, I was trying to be helpful, but I was zoomed in too much. If you have any questions, let me know, but hopefully this helps.